So there is the question that we had solved using graphical method. The very first question that we solved ilikuwa gani? Question we solved using graphical method. It was November 2019. Was it November? Yeah. The very first. Oh. The very first that we solved. We solved two questions. It was April 2022 question.
Question 6A, Roman 2.
6A, Roman 2. So, when you are solving using simplex, obviously any question that we're dealing with in linear programming, it must always begin with formulation. It must always begin with formulation. And I think for the interest of my space, I'd like to write that formulation somewhere here.
You can just switch on the lights.
Okay, will be okay. Eh? Okay. So for the formulation, I want you to read for me what we had. We had said that X represents
The units of product.
Units of product 1,
Produced.
units of product 1, and Y represents units of
Product 2.
product 2. Then objective function, we are copying again. Eh?
Yes.
Objective function is to maximize Z, which was equal to what?
8x plus
8x plus
11y.
11y. Now this was subject to
1.6x
1.6x
plus 1.0y,
1.0y,
which is less or equal to
8.
Then
Then
sheet A.
yeah.
For machine A.
That is machine A.
Then 2.5x plus 1.0y less or equal to 100.
This is for B. Eh?
Then xy
xy
should be
greater than or equal to 0. That is non-negativity. So copy up that point again. Non-negativity. You are through?
Yeah.
So if you are through, now after formulation, you remember we went to the step called solution. So we say solution using simplex method. Solution using simplex method. Solution using simplex method.
Lakini unajua hadi nikuja kuona azinadi hatujitumia kompyuta juu.
Sasa, when we are told to solve using the simplex, we say let S1 to be the slack variable for EA was machine, eh?
Yeah, machine.
For machine A. S2 to be the slack variable for machine B. Slack variable for machine B. Then objective function. Objective function is to maximize Z, which is equals to 8x plus 11y. Now, first of all, you may wonder how do we know we are coming up with these two? It is because of how many constraints we have. So each constraint is assigned one S. So if there were 5, we would have gone to S5. Then those S's, they come now and join this objective function, and they come with a contribution of 0. They come each with a contribution margin of 0. Now, subject to 1.6x plus 1y plus S1 is equal to 80. This is because of A. Then 2.5x plus 1y plus S2 is equal to 100. And that is B. That is B. Copy that way. And then don't draw anything. So have you copied at that point? Okay. So if you have copied, that is the first step that we take when we are using simplex. It is called changing inequalities. After you change the inequalities, you see now tumetoka kwa hizi, tumekuja kwa these ones. Yeah, that's called changing inequalities. We now prepare something called initial simplex table. Initial simplex table. Now, in this initial simplex table, we have a column here called basis, called C. Now, C will always be there in any table you draw. In any table you draw. The second column, which will always be there in any table, is called basis. It will always be there. Now, this basis in the initial table, where tunaleta the slack S1, and then you bring S2. Then from there now, you bring another one we call CJ, and another one called ZJ, and another one called DJ. These three rows will always be there in any table you draw. Then from there, we are going to have two columns here, then three others here. So this one will be the titles now, the titles after the basis, the titles are the items in this function. The items in this function. So we are going to have X here, we are going to have Y, we have S1, S2, and then there is BR. So this one's what it's supposed to be. Then here we allow a small space for something we call ratio. So design a table like that, be fast. Now, after you do that, this is the next step. This C here contains the contribution margins. Actually, we can even be putting it as CJ because it's the same like this one. But now for just these two. So contribution margin, as you can see, for S1 is 0, S2 is 0. So do that. Then from there, you follow the function where there is S1 here, this one, and you put those coefficients here. So X equal to 1.6, Y equal to 1, S1 equal to 1, S2 is not there, so it is 0, and BI is 8. You do the same with the second one. This is 2.5. This is 1. This is 0. This is 1. And this is 100. Then this CJ, you bring the values as they appear here. The contribution margins, as I've said, X has 8, Y has 11, these others have zeros. So even this one is put 0. Now for this one here, ZJ, we put zeros in the initial table because what happens, you multiply these CJs with the values that are here. And because these are zeros, then everything becomes 0 here. Comes 0. You just multiply these ones by these ones. We will have some working later where they will be values. But for the first one, you can cram. I think cramming is easier. That ZJ is always 0. But in other tables, we shall have workings by you and DJ is given as CJ minus ZJ. So 8 minus 0 is 8. This is 11. This is 0, 0, and 0. That is how you get it. So once you have filled the table, you check whether there is any positive value here. Do we have any? If yes, that table is not optimal. So if it is not optimal, but remember, for when you're using a computer software, it will be positive, even if it's optimal, but the software will tell you that the solution has become optimal. But nowadays, waitoa hiyo maneno, although niliona juzi ni kama walileta kaswali kwa hiyo, but that is supposed to qualify for 3 marks. So once you have seen it is not optimal, you pick the highest DJ. So these are DJs, the highest none, 11. So you circle here, and then this column where you have found it, where you have found that, is called key column. Where you have found that is called key column. The item at the title of the key column, this one, that item at that title is called incoming variable. Incoming variable. Si lazima ulepo where ulepo ni unaweza toa mshale yende wherever bora you are able to label that is the incoming variable, because where I'm putting maybe yours does not have space. After you have identified the incoming variable, the next thing is to compute what we call replacement ratio. Now, replacement ratio is obtained by getting these values in the BI divided by the values in the key column. So like now, this one, it will be 80, you divide by 1, which is 80, and 100, you divide by 1, which is 100. That is how you get the replacement ratios. And all these things that I'm talking, they are in your notes. Except the statement that they are in your notes. Everything else is in your notes. If you follow the notes, you see those steps. They are well implemented. Now, once you have gotten your ratios, you pick the smallest. So the smaller of these two is, where you have seen that, this one is called key row. Where you have found it, it is called kilo. And the item at the title of the kilo, this one, that item at the title of the kilo is called outgoing variable.
The S1.
Yes, the item at the title of the kilo. The item at the title of the kilo is called outgoing variable. The item at the intersection of the kilo and the key column, this one, is called key element. Is called key element. The item at the intersection of the kilo and the key column is called key element. At that juncture, we now prepare the second table because we found that this one was not optimal. So you now have to do the second table. Remember, the initial is like the first. So the second simplex table. The second simplex table. Now, when you are doing the second simplex table, I have already told you that any table you do will always have CJ and basis. Now, the basis values keep on changing as you do subsequent tables. And the change goes like this. Unakuja hapa kwa the previous table, you look at the first one. This one has already been labeled as outgoing. So it will go out and it is going to be replaced by the incoming. So the incoming is who? So here I will write Y. This one, it has not been touched. So it's going to remain S2. The other three, I told you they will always remain. These three will always remain. Then from there, these columns here, they don't change. The columns do not change. So I have a column for X. I have a column for Y. I have a column for S1. I have a column for S2. I have a column for BI and the space for ratio. So this is X, Y, S1, S2, BI, and ratio. So we can design that. Haya, kama umemaliza, the next thing that we do, unarudi hapa kwa hii table. You divide everything by the key element. So, tutasema hivi, first of all, maybe we tujaza hapa. Tumesema hapa, it is the contribution margin. So the contribution margin of y is tunajua ni 11. Sio?
Yeah.
Yeah. Haya, na S2 tunajua ni 0. Hapo ingine mtu atajuanga baadaye. Nasema oh ni hivyo. Si ndio hizi? Tumeongelea hapa, tukaongea hapa, tukaongea hapa. This is now the fourth time I'm talking about it. But that's the beauty of being a teacher. Sasa niko hapa. Nimesema we are dividing everything by the key element. So 1.6 divided by 1 is what? 1.6. This one divided by 1 is 1. This divided by 1. This divided by 1. This divided by 1. And then this row here that you have gotten, you can come down here and remove. It is called new row. Hiyo ile tumejaza. The one that we have gotten the values to correct hapo kwa inaitwa new row. Then hiyo ingine imebaki, this one, rudi hapo kwa hiyo meza, you call it old row. Now because they are just one, it's just one, you just call it old row. Lakini kama zingekuwa several, we label them as old row 1, old row 2 hivyo. Then there is a formula that is in your notes, that is now going to help us get the values of S2. That formula is going to be like this. Old row S2 value minus new row value multiplied by balancing figure, it will give you new row S2 value. Look at your formula. Old row S2 value minus new row value times balancing figure is equal to new row S2 value. So this is what you do. Old row tumesema ni you copy the values. Maybe you can first of all look at what I'm doing here. You copy those values. Kuna 2.5, imefuatwa na 1, imefuatwa na 0, imefuatwa na 1, imefuatwa na 100. Then according to the formula, we are supposed to say minus. Then you take these values of the new row. The new row hapa iko na 1.6, hapa ni 1, followed by 1, this is 0, and this is 8. Then you say times the balancing figure. Now, balancing figure, it is always the value at the intersection of the key column and the old row that you're dealing with. So this value here, which is at the intersection of our old row and the key column, which is 1. So here, then you say equals. That's a true calculator. I normally see students struggle with this issue of the board mass, but the easier way is put everything in the calc as it appears. So we get 2.5 minus 1.6 times 1 equals 0.9. Kuja kwa ingine 1 minus 1 times 1 equals 0. 0 minus 1 times 1 equals 1 minus 0 times 1 equals 100 minus 80 times 1. Yeah, now those values, ndio unakimbia nazo hapa kwa S2. So sasa hapa utaandika 0 point what? 9, hapa ni 0, hapa ni minus 1, hapa ni 1, hapa ni what? Yeah, that's how it's done. Yeah, mpaka hapo. Yeah, okay. Haya. Kuja kwa huyu. CJ, the values remain as I told you. So it is going to be 8. This is 11. This is 0, 0, and 0. Copy that. So twende kwa ZJ. I don't know whether you need to write that, but maybe for purposes of record. I told you ZJ, what you do, you take this value here, see, you multiply with this one. So like now for here, kwanza, that's 11 times 1.6 plus 0 times 0.9. Give me that answer. $17.6. Now that 17.6 ndio tutakuja tuandike hapa. Nikikuja kwa huyu Z2, I will again take 11 multiplied by 1 plus 0 multiplied by 0. And that gives us what? 11. The next one, Z2, no, Z3, it is going to be 11 times 1 plus 0 times minus 1. That is going to be 11 as well. Yeah. So this is 11, this will be 0, and this will be 8, 8. Sio iko sawa? Haya, tukikuja kwa DJ, nitakwambia DJ is supposed to be given as CJ minus ZJ. So 8 minus 17.6 is what? Yeah, 11 minus 11. Sasa, do we have a positive value hapa? No. So if no, that table is optimal. And if it's optimal, unakimbia hapa, you call it final simplex table. If it is optimal, you baptize it final simplex table. Final simplex table.
That's very, very you go to up to 3 tables.
You can go even to 10. But most of your questions, the farthest it will go is for 3.
3.
Yeah. You know, we are not teaching you, you are not mathematicians. So you're accountants. So we just give you something that will terminate very fast. But if you're doing a course like maybe applied mathematics or even the subject as operations research, you could get zinaenda huko. Yeah. Because now those ones are given there because the runner there, their specialization is mathematics. So it must give you good things. Lakini hapa your specialization is not in mathematics. So try to kusichua sana. And in any case, siku now for the accountants, we are using the computers. Now hata wameleta business analytics. Yeah, there is a course now, ukimaliza kufika hapo since utapata mstari hapo. Atakufunza how to do these things now using a computer. Yeah. There, business analytics. However, now the interpretation is still required this one. So what we are doing here is to help you appreciate the interpretation. Because that's how when you utapata hapo, you will not be able to interpret. Like now, what we are doing now with our section 6, Mr. Ruto is teaching the computer how do you do the Excels, how do you do the shells, how do you the sheets, how do you convert them, those formulas, how do you incorporate. Sasa yeye anatoa data, lakini akitoa data he may not be able to interpret it from an accounting perspective. Sasa na mimi nitaenda hapo niseme ukiona hii inamaanisha hivi. Like now yeye atakutolea hii. So what does it mean? That's now when I come in and I tell you like what I want to take here. Optimal solution. So I told you when it comes to optimal solution, you give us two things. The first thing is production. When it comes to production, you must tell us how many units. Remember, we have a product called product 1, which was represented by X. So this is what you do. Unakuja hapa kwa your table. Unaangalia in the basis column. Una X hapa. So if it is not there, kumaanisha we are doing 0 units. It will not be produced. Then unakuja kwa product 2. Ilikuwa imesimamiwa na what? Y. So unakimbia hapa. We have Y. So if we have it, unakimbia mpaka huku mwisho. It has how many units? 8. So we are going to do 8 units. Alafu, the second thing that I told you must tell us is profit. And I told you profit, we look for the maximum. Now the maximum, hii value iko hapa ya mwisho. 8, shillings, 8. But you don't pick it as negative, you pick it as positive. Now, are these the solutions we got? Before angalia kwa graph, when we solve using the graph, this is what we got. Yeah. The first question to be using the graph. See, those are the answers. So sasa ukishamaliza hiyo ingine tulijibu utasolve on your own. Unaona the check. Ukipata hiyo answer, ujue umefanya vizuri. You don't, umepotea. I told you as long as you are below 50, even 1 mark is very important. Yes, Cohen, I can see that. So we are through, eh? Which question?
Question 2B.
Nauliza nini?
Sorry, I just question 2B.
It's not part of this. Is it?
This.
Kwa hii swali basi.
Oh.
Hii tumemaliza. Have you copied up to 8:8?
Yes.
Umeelewa mpaka hapo?
Yeah.
Good. So kama umeelewa mpaka hapo hiyo swali basi tumemaliza. Sawa. Haya. Hiyo basi unauliza hiyo ni assignment. Hiyo ni assignment. Hiyo ni assignment. Kwa hiyo unaweza kufanyia, acha nifanye yenye niwezi kufanyia. Anyway, that one does not require you to solve, eh? And today I'm solving. Yes. So I want to do that one requires interpretation. That one that you're asking, it only requires the into simplex table, and then you interpret the table in chart, right? So I want to do a question that you will solve. Kimbia kwa hii ya September 2021. September 2021. Sasa nifanye, najua hiyo tumechukulia juu. So nataka tufanye fresh ama new one. Ile ndio wa secret. Angalia question ndani. Question 2B, September 2021, question 2B. And this one must be extremely fast because it has more tables and I would want us to finish. Sasa, because I can see we have like an hour. So hakikisha unatembea haraka. Zakem Limited produces two products, namely alcohol and xenon. The products pass through 3 departments, namely assembly, finishing, and packaging. There is a maximum of 200 hours in each of the assembly and finishing departments. In addition, a maximum of 400 hours of packaging are available for packing alcohol and xenon. The table below shows the number of hours required per unit of each product. Each unit of alcohol and xenon gives a profit contribution of 3,000 and 2,000 respectively. Formulate. So we do the formulation. I told you, for you to do the formulation, you must have known 3 things. The first one is the objective. So is this question about maximizing or minimizing? Why? Naona kuna the mention of the word profit, eh? Yeah, and even if it's not mentioned, na umepewa selling price na cost, then bado ni profit, eh? Yeah. Then the second thing that you must know is the variables, and I told you those are the products. So which products are in this question? We have alcohol and xenon. Good. The third thing I told you must be able to identify are the constraints. And a constraint is a resource whose quantity, the maximum quantity available has been given. So which constraints can you see here? We have the assembly, finishing, and packaging. Sasa ukishaelewa hizo formulation you are done. So that now you come here and say, we can still use X. I don't know whether if I use X, kila mahali itakuwa X. Can I change? Yeah. Kwanza nitumie hiyo ndio uelewe. Let me still use that. Let X represent units of alcohol produced and sold. Let X represent units of alcohol produced and sold. Y to represent units of xenon produced and sold. Produced and sold. Then objective function. Objective function is to maximize Z. What is the contribution margin of alcohol? The profit per unit of alcohol
is 3,000.
3,000. Na huyo mwingine ako na 2,000. Higher. Subject 2, we now bring the inequalities. The first one will be 2x plus 3y is less than or equal to assembly to B1 is 200. So this is assembly hours. Assembly hours. So umeona 2 na 3 mahali kumetoka. Haya. 4x plus 2y is less than or equal to 200. This is finishing hours. Finishing hours. The next one is 5x plus 3y is less than or equal to 400. And this is packaging hours. And obviously, tumekuwa tukisema x, y is greater than or equal to 0. And that is non-negativity. Non-negativity. Kishamalizana na huyo formulation, you now go to solution using simplex method. Solution using simplex method. Now, in the solution, I have told you that the first thing is to change the inequalities by introduction of the S's to present the slack variable. And I've told you those S's, they depend on how many inequalities we have, how many constants. Kama hapa tuko na ngapi? There are 3. So we begin by saying let S1 to be the slack variable for assembly hours. S2 to be the slack variable for finishing hours. S3 to be the slack variable for packaging hours. Then objective function. Nimekwambia kwa objective function tunasema maximum or max z equals 3000x plus 2000y. Then I've told you these S's come in and they come in with contributions of zeros. So this is 0s1 plus 0s2 plus 0s3. Subject to. So unachukua hii ya kwanza unasema 2x plus 3y plus s1 is equals 200. You can tell us ni assembly ama ukose kurudia because already tunasoma sinaona hapa. Yeah. Then 4x plus 2y plus s2 is equals 200. 5x plus 3y plus s3 is equals to 400. Now, although your syllabus has restricted me from going deeper into this, maybe I need to explain what we mean by slack variable. Slack variable means the resource that remain unused. And this is how you can explain it. When I say this 2x plus 3y is less than, I am saying we could get, you can get something less than 200. Tuseme upate 190. Ama, now that is when you say it is less than, right? Then it could also be equal to. So tunasema mambo mawili. It can be less than 200 or it can be exactly equal to 200. Now, in the event that it is not equal to 200, what we do hapa si tumebaki 10. Now, this 10 ndio inakuja kusimamiwa na this S1. So that this plus this 110, 190 plus 10 zinaenda to what? Lakini kama hii na hii ni 200, then S1 will be what? 0. That's all. So slack variable means the resource that remains unused. Yeah. Like now, in class, these chairs that you see here, these are slack variables. They are unused. Haya, sasa kutoka hapo nikakwambia tunatengeneza nini? Initial secret state. So now that you have an idea, tunasonga pamoja. Unajua inakaa namna gani? Initial secret table. You can write your title. kuna S1, kuna S2, kuna S3, kuna CJ, kuna ZJ, kuna DJ. So initial simplex table. So hapa takuwa na CJ, alafu tukue na basis. Nimekuambia something here. The titles of this table are the values or the elements in the objective function hapa. So utakuwa na xy, s1, s2, s3, eh? Yeah. So niko na x there, niko na y, niko na s1, niko na s2, niko na s3, niko na bi, and then begin in the back the ratio. So I have x here, y, s1, s2, s3, and bi. Alafu tena nikakwambia kwa the first table uba tunaanza hapa na s. So s1, s2, s3, kuna cj, kuna zj na kuna dj. And hapa in case there will be need, we'll have ratio. Tumefika hapo eh? Haya, kama tumefika, nikakwambia hapa huwa tunaweka the contribution margins of the S's. So this is 0, this is 0, and this is 0. Then hii line ya S1 tunafuata hii equation where there is S1. Ndio tuweke 2, 3, 1, 0, 0, and 200. Huyo mwingine naweka 4, 2, 0, 1, 0, and 200. And the last one is 5, y is 3, hakuna S1, hakuna S2, lakini kuna S3, and the total is 400. This other one for CJ, X equal to 3,000, Y equal to 2,000, S says the zeros. Alafu ZJ ilikuambia in the first table na zeros. Then you subtract, this is 3,000, this is 2,000, that one. Now, do we have any positive value here? So the table is not optimal. So if it's not optimal, pick the highest. So if 3,000, let me do again. Tumesema hii column inaitwa key column. Where you have found the highest value inaitwa key column. Alafu huyu value of this item that is the title of the key column inaitwa incoming variable. Inaitwa incoming variable. Incoming variable. Tena unakimbia nao pale kwa ratio, where you divide these PIs using the values in the key column. So hii ya kwanza nitasema 200, you divide by 2, that gives us 100. Huyu mwingine 200, you divide by 4, that gives you 50. This other one is 400, you divide by 5, that gives us 80. After doing that, nikakwambia sasa uchukue the lowest. The lowest kati ya hizo tatu ni 50. So this one is called kilo. Then, this item that is at the intersection of the kilo and the key column, this one here. Inakwambia inaitwa key element. The item which is at the intersection inaitwa key element. Alafu huyu mwenye ako kwa title ya kilo, nikakwambia anaitwa outgoing variable. Naitwa outgoing variable. Ukishafika hapo, we can design the next step. we create design. So this one is called second simplex table. And as I told you, the titles remain. So I have CJ followed by basis. So here I have X, Y, this is S1, this is S2, this is S3, this is BI. Then in case there will be need, tutakuja hapa kutafutarishi. In case there will be need. Sawa. Sasa tunakuambia hapa, unakuja unaangalia huyu hajaguzwa, so they remain S1. Lakini huyu ameguzwa, so will be replaced by the incoming. Incoming is X. S3 haijaguzwa, then we have CJ, we have ZJ, and we have DJ. Fanya hivyo, this S1, the contribution is 0. X, the contribution is what? 3,000. S3, 0. To be fast, you have that point. So if you have that point, now we need to create the new row. And I told you new row is created like this. Unakuja hapa kwa the key row, you divide everything by the key element. So 4 divided by 4 is 1. So inaandikwa hapa kwa, you see the corresponding period. 2 divided by 4 is 0.5. 0 divided by 4 is 0. 1 divided by 4 is 0.25. This one is 0, and this is what? 50. And then this one, we will call it the kilo. Not the kilo. We will call it the euro. We will call it the euro. We will call it the new row. Sasa from there, you need the formula that we have. And because tunataka kuanza na hii S1, itabidi tukuje hapa tuseme odd row S1 value we minus new row value multiplied by balancing figure that will give us new row S1 value. New row S1 value. Haya, twende kwa odd row S1 hii. The values are 2, 3, 1, 0, 0, and what? 200. Then you say minus. You say minus. That's how you minus, you bring the new row. The new row is S, we have 1, we have 0.5, we have 0, we have 0.25, we have 0 and 50. Then you say times. You say times. Balancing figure. Now the balancing figure is the figure at the intersection of the odd row, hii tunadeal nayo na key column, which is these two. That's 2. So this is 2, 2, 2, 2, 2, 2. You need a calc. 2 minus 1 times 2 is what?
0.
This other one?
2.
The next one?
2. 1.
The next one? Very simple things. Haya, sasa hizo unakuja unakimbia hapa unaweka 0. This is 2, this is 1, this is negative 0.5, this is 0, and this is 100. Haya, sasa tunataka tujaze ya S3 eh? So tutarudi pale tuandike formula tuwe na old row S3 so that we will get the new row S3. So mine I'll just adjust here. So you write the formula again. So tuandike the old row value, kuna 5, kuna 3, kuna 0, kuna 0, kuna 1 na kuna 400 eh? So hii new row they still remain eh? They still remain. Alafu the balancing figure ni hii 5. That 5 so compute, give me the answer. And so the first one is 0, 0.5, 0, negative, is it 1?
Yeah.
Oh, yeah, it's 1 because we are more than 1.25, eh? 0. Oh, sorry. 1. Alafu sasa ingine nitakuwa 150. Haya, hii CJ nikuambia that one does not change, so we bring 3,000, then 2,000, then 0, 0, 0, 0. Si sawa hivyo? Haya. Ile ingine tunastahili kujaza ni ZJ. ZJ, I gave you the formula of how to go about it. Nikakwambia you take these values, hizi ziko kwa CJ na multiply na hizi. Maybe if I write the first two, Z1 nitasema it is 0 times 0 plus 3,000 times 1 plus 0 times 0. So the answer will be 3,000. Ikikuja kwa Z2, it will be 0 times 2 plus 3,000 times 0.5 plus 0 times 0.5. So that is 1,500. And as you can see now, these two are zeros. So the only one that is working here is 3,000. So we can now quickly go 3,000 times 0 is 0. I'm going to go at the base right there. Umeelewa? Hii umepata? 750. And this other one? 150,000. Sindio? Then hiyo ingine tukasema DJ is ZJ, no, CJ is CJ minus ZJ. So sasa hii itakuwa 0, hii itakuwa 500, hii itakuwa 0, hii ni minus 750, hii ni 0 na hii ni minus 150,000. So hebu imejaa. Do we have any positive value there? So our table is not optimal. So the procedure again. Procedure again. So tuanze. If they are not optimal, the highest happening. Do you have to keep on recording?
No.
Sasa tumeelewa. So sasa hiyo ndio tunasema itaitwa keyword. Key column. Key column. Haya, huyu mwenye ako hapa juu tukasema anaitwa incoming variable. Incoming variable. Ukishajua incoming variable unakimbia sasa huko kutengeneza ratio. Whereby utasema ni 100 divided by 2. That is 50. Huyu mwingine 50 you divide by 0.5. That is 100. 150 divided by 0.5. And that is what? 300. Ukishaweka 300, umesema you go for which one? Kati ya hizo tatu unachukua nani? Why? It is the lowest. Good. If it is the lowest, you circle that, and that row will be called who? It will be called key row. Then where the key row? So hii ndio sasa key row. So sasa iteremke hapa niite key row. Tena nimekuambia where the key row meets who? The key column. This value here. This one tunamuita nani? Anaitwa key element. This is the favorite table to carry. Key element. Key element. Alafu sasa huyu mwenye kwa hii title hapa nilikwambia anaitwa outgoing variable. But in exam, you don't have to keep on labeling this way. I'm only labeling so that as we need, you are able to quickly connect. You don't have to keep on labeling. So, ukiwa hapo, now we draw the third simplex table. Third simplex table. And I have told you the first row is always CJ, followed by who? Basis. Angalia hapa ndio to design CJ. I mean this one. So ukikuja hapa nikakwambia unaangalia nani ameguswa. So mwenye ameguswa hapa ni S1. Who we have called out. So it is going to be replaced by in Y. So this will be Y. Then here X itaguswa, so itabaki. ES3 itabaki. Alafu CJ. Alafu ZJ. And then I will have DJ there. The other thing tumesema is that the titles will always remain as they were in the other table. So I will have a title for X, a title for Y, then I have S1, then I have S2, then I have S3, and then I have BI. Now unaacha ka space in case you may require the ratio. So this is X, this is Y, this is S1, this is S2, this is S3, and this is BI. Sawa, eh? Haya, quickly write that formula. Now, hatujafika kwa kuandika formula. Tumesema after the table is in place, you divide the values in the key row using the key element. So the key element is 2. So tutaanzia hapa 0 divided by 2 is what? 0. Maybe kabla tuandike hiyo, acha tuandike the contributions. Y iko na contribution ya 2000, ndio? X iko na 3000 na S3 iko na 0. Sio iko sawa? Haya, 2 divided by 2 is 1. 1 divided by 2 is 0.5. This one will be minus 0.25. This is 0 and this is what? 50. So this now will be my new row. That will be my new row. Hiyo iko sawa? Sasa kama hiyo iko sawa, kuja hapa tuandike formula. Nao tunatafuta kujaza hii x na hii f3 ya. So sasa tutasema odd row x ndio tuende tupate the new row x. Umeandika eh? Haya, tuende kwa odd row x. Iko na 1 na 0.5 na 0 na 0.25 na 0 na kuna 50. Those are the odd row values. Then you quickly say minus. Actually, hata ukiwa umeandika formula vizuri, lazima ushinde ukiandika signs, unaandika tu hizo values kifuata hiyo majina. So new row niko na 0, I have 1, I have 0.5, I have minus 0.25, I have 0 and I have 50. Then you quickly say times. We can say times. Now that times, tumesema it is the key what? Key column and the odd row that we're dealing with. So, sini 0.5 hapa. Sindio? Get those answers. These are the answers. 1. And it is not dropped. It is not dropped. Na wengine wako ndani. Haya, 1. Maybe she's using the wrong whatever. Then 0. Sio iko sawa? Tukimbie nao tufanye F3. S3, old row S3. So old row S3 tutabadilisha hawa. So nileta hizi values za S3. I have 0, I have 0.5, I have 0, I have negative 1.25, I have 1, and I have 150. Alafu hii balance figures bado ni 0.5. So inabaki. So quickly do that. Tujaze hapa, alafu hapa tunajua ni 3000 na hii ni 2000 0 0 0. So jaze hizo zingine zimebaki quickly. Aha, hapo umepata 0 0. Aha. Aha. Haya. ZJ hapa
3000.
aha
2000.
aha
1750.
aha eh
625.
625.
Then 0.
Uh-huh.
$175.
175. So this one then would be 0, 0, negative 1750, negative 625, 0, imesema 175,000. So si hakuna positive. So that is now our final simplex table. Final simplex table. So the interpretation or the optimal solution, which is a part of the optimal solution, so I want to start with profit. So profit maximum, nimekwambia hii ya huku. So that is shillings 170. Yeah. Haya, huyo mwingine ni production. And because of that question Mercy you are asking, which is not part of your syllabus now, kuna tu vitu wameongeza but they are not part of the syllabus. I want to frame this in a way that you'll be able to interpret that. So for the production, we have the product here. Then we have something we call units made. And then we have the shadow price. Shadow price is also called reduced cost. It's also called reduced cost. We got two products. We had two products. Huwa tunaipeana as a table. So tulikuwa na product alikuwa anaitwa Alcon. And in our workings, Alcon ilisimamiwa na X. Then tulikuwa na mwingine alikuwa anaitwa Xenon. Na huyu Xenon alisimamiwa na Y. Shadow price or reduced costs. Si mnajua opportunity cost from economics. Yeah. The same thing. So nilikwambia unakuja hapa kwa basis, unaangalia kama hiyo product ibaki hapa kwa faida. So Y is equal. So unakimbia huko mwisho, it has what? 50. X equal. No, sorry, hii ndio X. X iko na 25. Na Y iko na 50. These DJs, these ones, they are the dual costs or the shadow prices. So ukiulizwa the shadow price inakuja hapa kwa X na soma hii hapa chini. 0 0. Huyo mwingine that we need to interpret anaitwa resources. This one is completely out of your new syllabus, but because walileta hiyo kaswali so we have the constraints or the resource. Now the first one ilikuwa inaitwa assembly. So we had assembly hours. Now these assembly kwa our whatever zilisimamiwa na S1. Huyo mwingine alikuwa anaitwa finishing hours na ilisimamiwa na S2. Alafu mwingine alikuwa anaitwa packaging hours alikuwa amesimamiwa na S3. Those are the resources. And the first thing is to know whether it is whether there was a surplus. Ushaandika surplus? Andika slack. Although huwa tunaziandika zikiwa zote mbili, slack stroke surplus. Sasa sitashinda nikikuambia the difference because it's not even in the syllabus. So sasa huwa inasomwa hivi. Unakuja hapa. Unaangalia S1 imebaki hapa. So kama haijabaki ni 0. S2 imebaki 0. S3 so unakimbia huko mwisho imebaki what? Hiyo ni kumaanisha the packaging hours tabaki 125 unused. Kuna kitu kingine yenye inaitwa dual cost. And this dual cost, it is also what I'm calling shadow price. Actually, this D, not a D, is the first letter of the dual cost. First letter. So just like I've shown you how to read the shadow prices for the product, you read the same. So nakimbia kwa S1, that is 1750, lakini unaileta ikiwa positive. Huyo mwingine naleta 625, na huyo mwingine ni 0. The result that you're supposed to cover, I used to teach this with almost 3 weeks. Linear programming, it is so good. But also with your new syllabus, 2 days are enough. Like now tumemaliza. So you can be sure I've already touched the introduction. So if you give it a further interest, you'll be able to get this. Now, 2 things. One is I'm going to send you some 2 other videos that are taught simplex, so that maybe you can use them to revise. The second thing is that tomorrow we begin a new topic, and I'm going to send you the notes immediately after this. You can have a look at those notes and discuss them tomorrow.